It's crazy to believe we haven't been there in 50 years.
April 2019. For the first time in history, a private company is attempting to land on the moon.
They want to do the impossible. This is literally their own moon landing.
No private organization has ever done this before.
This is the first private lander to land on the lunar surface.
What began with 3 engineers determined to win the $20 million Google X Prize is now on the brink of one of the greatest milestones in private space exploration. But it all comes down to sticking the landing.
6, 5.
There are so many things that could go wrong.
Right now, you're looking at a live view of Falcon 9 at Cape Canaveral, Florida, as it awaits its 8:45 p.m. Eastern Time launch.
All stations verified, ready for launch. Ground go.
This evening's launch is a rideshare mission, including the first privately funded lunar spacecraft.
An interesting fact about this lander is that it will be using its own power to travel to the moon, which will take nearly 2 months.
People don't realize how difficult it is. It has literally been only the United States, the Soviet Union, and China that's gotten to the moon's surface. SpaceIL, a private company flying the Israeli flag, will be the 4th entity to land on the moon. And that is huge.
We're currently at T-minus 10.5 minutes until launch.
Rock.
Rock, go.
There are so many things that can go wrong in a launch.
I used to be on the launch team for the space shuttle, so I've been in a lot of countdowns. And I can tell you that it's worse than nerve-wracking. It's terrifying at times.
Things can go wrong. And if there is a catastrophic failure on launch, then you lose everything.
Even the best rockets
Falcon 9 looking good for launch.
have only a 97% success rate.
Our history of exploring the moon dates back more than 15,000 years to when humans were first looking up and becoming aware of what lies above the Earth. But it was only in the last century that going to the moon started to turn from something which is science fiction into something that could potentially be a reality.
Since the 1950s, only the Soviet Union, the United States, and in 2013, China have put spacecraft onto the lunar surface. These 3 countries were all superpowers.
But what we're seeing now is this pendulum shift in terms of space. It's no longer just about governments, it's about individuals and private companies as well.
החללית בשיגור מגיעה למהירות מקסימלית בפריגי זה הנקודה הכי קרובה לכדור הארץ.
A non-profit company named SpaceIL is about to launch a module into space with the goal of landing on the moon and conducting a series of experiments.
We're living during the most extraordinary time ever, where individuals and small teams can do what only nations could do before. And small teams can take risks that large corporations and governments can't take. And the day before something is truly a breakthrough, it's a crazy idea. It's a risky adventure.
This mission is a real milestone. No private organization has ever done this before, landed on another body anywhere in the solar system.
The 2-stage Falcon 9 rocket stands 70 meters tall. That's greater than the wingspan of a 747 aircraft. The SpaceIL lunar lander is safely enclosed inside of the 17-foot diameter payload fairing, which is this pointed cone at the very top of the vehicle. This protects the payload from aerothermal loads, heating, and contamination during ascent.
10 years ago, this was not on the drawing board. There was no way, a decade ago, any private entity could pull off something like this mission.
Today, we're challenging private teams from around the world to design and build robotic explorers and race them to the surface of the moon.
In September 2007 in downtown LA, I took the stage alongside Larry Page, who was then the CEO of Google, the Deputy Administrator of NASA, Apollo 11 astronaut Buzz Aldrin, and we announced a $20 million first place prize for what we called the Google Lunar X Prize. We challenge teams from around the world. If you're the first person to build a robot, launch it, land it on the moon, send back photos and videos, you'd win the cash prize. Didn't care where you were from, it had to be a privately funded team.
It basically was to inspire people to go to the moon. Putting this prize in front of these private companies is what really got people going.
In November 2010, a young engineer named Yariv Bash hears about the Lunar X Prize and has a crazy idea.
When I heard about the competition, I posted on my Facebook wall, who wants to go to the moon?
Two friends, Kafir Damari and Jonathan Weintraub, respond, and the three meet at a local bar in Tel Aviv.
You can actually see the first sketches that we did of the spacecraft and what are the problems and what is the timeline and everything that we thought that how the spacecraft would look like.
It's fascinating because of the three, only one of them really had any aerospace background. The other two were electrical engineers and computer scientists.
But they said, hey, let's do this. Let's put together a group and go to the moon.
The odds that this would all come together are crazy, right? This is a really big idea.
In the rush of excitement to compete for the prize, these three visionaries have no idea how long and difficult their quest will turn out to be.
Space is hard, and they learned that real fast. And if space is hard, landing something from space is even harder.
The biggest challenge in building spaceflight hardware is simply the experience to be able to build it. Getting that experience can't be obtained any other way than by doing it. And SpaceIL started from scratch.
They had a lot of challenges, and one of those challenges was simply coming up with the money.
And then through a chance meeting at a conference, they met this incredibly wealthy individual called Maurice Kahn.
They said that they were going to put a spacecraft on the moon. I said, come to my office, and I gave them $100,000, no questions asked, and I said, start.
To maximize resources, the SpaceIL team makes use of 3D printing technology.
SpaceIL has put so much of its innovation into designing the legs of the spacecraft. They came up with this aluminum honeycomb, which is meant to absorb energy during impact with the surface of the moon.
And the legs on Beresheet were actually 3D printed.
Which is a relatively new technology when it comes to space exploration.
Which essentially means you use a computer model to print in 3D.
But with 3D printing, you can manufacture and make changes on the fly.
This cutting-edge technology helped SpaceIL save construction costs on the module, along with its innovative design.
They didn't put a lot of thermal protection into it. It's got minimal navigation systems.
It's a small lander. It's only about 350 pounds without fuel and about the size of a kitchen table.
And they worked with a lot of so-called off-the-shelf items. And they had to make all of these thousands of components work together.
This is how they can put together a much less expensive mission. Any one thing could fail and end the entire mission. It's either going to break or it's going to get to the moon.
By hitching a ride on a Falcon 9 rocket operated by Elon Musk's SpaceX company, SpaceIL's fuel costs are significantly lower than if the module were flying solo.
SpaceIL's lander is not the only thing that's being launched. It's kind of riding shotgun on this Falcon 9 rocket.
The SpaceIL module will ride along with two other payloads, a top-secret U.S. Air Force smallsat and an Indonesian communication satellite.
It's almost like the Uber of space travel, so to speak.
The Soyuz launch vehicle, the space shuttle, these are billion-dollar launch vehicles because you throw them away. But the Falcon 9, because you're reusing a significant portion of it, is able to bring the cost down by a half, by 75%, eventually by 90%.
It sounds like science fiction when you think about it, launching this rocket up, having the payload continue on with the second stage, and then the first stage of the rocket, which is the bottom bit, then flips around and fires retro rockets, and it slows itself down and is able to land on a barge in the middle of the ocean. That's ridiculous.
By 2018, after 8 years of work, the SpaceIL team is close to completing their final design. But the Lunar X Prize deadline is approaching fast.
It had a deadline, and that deadline had been extended quite a few times as these companies ran into different challenges.
And when March of 2018 finally came around and we went for one more extension, it was one extension too much, and we agreed to sunset the prize, to shut it down.
After the Google competition was withdrawn, many of the teams stopped development.
At that point, SpaceIL already had its lander designed and had a rocket set for it, the SpaceX rocket. They were so close that they could feel it, they could taste it.
But SpaceIL was stating that they will have to stop operations.
They just ran out of money. They said, this is going to die if we don't get the additional help that we need.
SpaceIL was a done mission. It was out of their hands. Over.
February 21st, 2019. All systems are go on the launch pad.
Launch director, verifying. Go for initiate terminal count.
The first private space flight to the moon is minutes away from ignition.
Falcon 9 uses rocket-grade kerosene, which you might hear us call RP1, and liquid oxygen as the oxidizer. Currently, fuel is nearly fully loaded.
T-minus 4 minutes.
But this mission almost didn't make it to this pressure-packed milestone. Google and the X Prize Foundation withdrew the $20 million prize, and the SpaceIL team was out of money.
They have to go back to original investors, and fortunately, somebody was able to step in and say yes.
We've got the money, and whatever we don't get, I've underwritten. This project will not stop and not have any problem because of money.
The Google Lunar X Prize. You might think that was a failure, but it didn't fail. It was a tremendous success. It had exactly the intended outcome.
Even with the prize purse not there, the prize had served its purpose of incentivizing teams to build the hardware, to build the technology.
You can see the 4 fuel tanks to take us from the Earth to the moon.
It inspired these teams to shoot for the moon.
SpaceIL were going to go ahead and finish the mission, whether there was a prize or not. The prize was putting the lander on the moon.
Finally, as the launch date approaches in late 2018, the SpaceIL team announces a novel way of naming their spacecraft, an online popularity contest.
It had to be a female name in Hebrew, and the winning name is Bereshit.
Bereshit is Hebrew for in the beginning.
It is the first word you see in the Old Testament, in the beginning.
And it's really symbolic because this is the beginning of a new period, the beginning of everybody all over the world having access to space.
And the moon is a perfect way station for us to gain access to the rest of our solar system. On the moon, we have access to silicon for solar cells, metals for construction, water in the lunar poles.
One of the greatest discoveries of the last couple of decades is that the moon has water. The water on the moon is harder than granite. It's frozen solid ice. So mining water on the moon is literally the same as mining a rock. And we have companies like Honeybee Robotics building the drills because the water on the moon can be split into hydrogen and oxygen, rocket fuel. And there's a lot of water. A lunar geologist has estimated that it's enough to launch one space shuttle every day for 1,000 years.
And it's beautiful to see that entrepreneurs are going to drive our future over the next decades and centuries ahead.
That's what is so brilliant about this SpaceIL mission. They are demonstrating we can access the resources of space, do mining and manufacturing beyond planet Earth. The moon is our launching pad to the rest of the solar system.
It's truly the beginning of the human exploration of the cosmos in a way that's now irreversible.
With 8 years of development and testing, and now a name, the Bereshit is almost ready to begin her adventure. But one enormous logistical problem has to be solved first that has nothing to do with space travel. how to get this strong yet delicate craft from the facility in Israel to Cape Canaveral on the southeast coast of the United States.
They had a special container, absorbing shock, humidity controlled, but I can tell you, having talked to a lot of other people who've been through this, it is a very anxious time for the people who built that spacecraft.
When you think of it, it's just metal and, science instruments and computers all jammed together, but there's this kind of human connection to these spacecraft, right? I mean, there are people that spent years and years of their lives working on this thing.
You don't want to drop it, you don't want it to get shaken, you don't want a sudden jolt to break the spacecraft, which is your baby.
As the flight touches down in Florida, the SpaceIL crew in Tel Aviv breathes a quick sigh of relief. But once the module gets into position on the launch pad, tension ratchets up quickly. Because moving the liftoff would require extra fuel to adjust orbits in space, timing for launch is critical.
We're currently at T-minus 3 minutes and 37 seconds from liftoff.
There's a lot that can go wrong during a countdown.
Falcon 9 is now moving into the final stages of countdown.
It could be that there's a piece of metal that gets weaker when it gets cold.
The vehicle remains healthy. We're currently tracking no issues.
There's glitches with computers, there's glitches with software.
It could be just one line of code, a comma instead of a period. There are so many things that could go wrong.
In preparation for the riskiest part of pre-launch, the automatic fueling process, all ground personnel vacate the launch pad.
The first and second stages are both nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen.
You're using liquid oxygen, which is so cold, to ignite this engine, which is creating flames the same temperature as the sun.
At T-minus 1 minute, the rocket's internal computer begins final pre-launch checks, and Falcon 9 enters startup.
The rocket's autonomous internal flight computers have taken over the launch countdown.
It's kind of like sending your kid off to college, right? You just got to let it do its thing.
At T-minus 30 seconds, the launch director gives the final go for ignition.
Go for launch.
It's basically a controlled explosion. In the case of SpaceX, which has 9 engines, it's 9 controlled explosions that are happening separately.
The rocket could blow up. And it has happened to SpaceX rockets.
Years of your life are about to either go into space or blow up and become dust.
2, 1, 0.
Currently, everything is looking good for launch. The last weather balloon was launched just a few minutes ago, and it looks like we're within load limits.
The dedication of hundreds of scientists, engineers, and supporters is about to face the ultimate test. Will the lunar module, named Bereshit, launch successfully to begin its 4 million-mile journey to the surface of the moon? As SpaceIL Mission Control makes final calculations, 6,500 miles away at Cape Canaveral, the onboard computers of the towering Falcon 9 begin the launch sequence.
You have an enormous amount of fuel, an oxidizer, the very thin metal skins of that rocket. SpaceX has had a lot of successes, but like everybody else, they've also had a failure. You basically have a payload sitting on top of a gigantic bomb.
And just imagine how you'd feel if you worked your entire life for something and to know that it could be obliterated in a matter of seconds.
Just before liftoff, the rocket's autonomous launch control triggers the water flooding system called Niagara to minimize the risk of an explosion.
10, 9.
At T-minus 3 seconds, the 9 Merlin engines of the first stage ignite.
1.
see the night sky light up with this firework, this giant candle, is truly awe-inspiring. And to know that you have something you created on top of that, well, that's just incredible.
Vehicle supersonic.
At 60 seconds, Falcon 9 reaches supersonic speed. Moments later, the rocket experiences Max Q.
Max Q is the time of maximum stress, not just for the rocket, but for the payload sitting on the top of that rocket. And some of them, no matter how well they're tested, don't quite make it through Max Q.
The combination of velocity and air density is the worst possible combination. You could have a failure of your struts, your structural systems in the rocket.
The next hurdle is the detachment procedure. 2.5 minutes into flight, the rocket reaches an altitude of 35 miles above Earth, with a speed of more than 4,500 miles per hour. The first stage engines shut down.
MECO.
This is nicknamed MECO, for main engine cutoff.
When the rocket is out of fuel, the engines are shut down, and the second stage will kick that first stage away.
In this thin atmosphere, the Beresheet no longer needs the Falcon engines to propel it through space. The first stage returns to Earth to be used again on a future mission.
Stage 1 entry startup.
And their entry burn has begun. Stage 1 will be coming back home to Earth.
That first booster carefully maneuvers itself with some smaller rockets to land on a drone platform in the ocean.
A few moments later, the single engine in the second stage ignites to begin a burn that will carry the Beresheet into low Earth orbit. Then, to release the latches on the protective nose cone, a command from Launch Control
Bearing separation confirmed.
triggers a high-pressure blast of helium.
The payload fairing is the aerodynamic nose cone that you see on the top of the rocket. Once the rocket gets outside the Earth's atmosphere, it's just extra weight. You don't need to carry anymore, so they throw it off. It falls into the ocean.
Approaching SECO 2, second engine cutoff.
Evac shutdown.
And confirmation of MVAC shutdown there. Next, we'll begin deployment of today's payloads.
The rocket's work is finished, and the Beresheet separates from the second stage to begin its solo orbit.
אני חושב שהרגעים הקריטיים יהיו כשאנחנו נתחיל את הקשרים החללית ונבדוק שכל המערכות תקינות. זה הולך להיות הרגע האמת הראשון.
Several minutes after detachment, the first signal from the radio transmitter on board the Beresheet hits the control room in Tel Aviv.
After separation, we're seeing telemetry coming from the spacecraft and sending command.
Now the spacecraft is independent and we control it. "35
minutes after takeoff, the Beresheet is in lower Earth orbit, but the craft still has 4 million miles to go. This elegant path is not the fastest route to the moon. The Apollo 11 mission took only 4 days to make the trip, but the Beresheet will take about 7 weeks to get there.
Rather than going straight to the moon, which would require a lot of fuel and a much bigger lander, what they've done is taken advantage of the gravity of Earth to slingshot around a couple of times.
As it goes further away from the Earth, its velocity slows down, and then when it comes closer, it speeds up. And then it fires its engines at its fastest velocity when it's closest to its Earth, and that pushes it into an even bigger elliptical orbit.
It will become this big oval over 2 months' time, and it'll keep raising this and raising this and raising this again.
And this basically transformed the journey from around 250,000 miles to around 4 million miles.
You can make an analogy to swinging on a playground. At the very bottom of your swing, when you're closest to the Earth, that's when you go the fastest. As you're rising higher and higher away from the Earth, you go slower and slower until finally you're not moving at all, and then you start falling back again.
If you launch with enough speed and enough energy, then that falling back towards the Earth, gravity pulling you in, is going to cause you to fall all the way around the planet. So the Earth's gravity is bringing you towards the planet, but since it's curved, you're falling around the outside edge.
It's February 25th, mission day 4. The Beresheet prepares to raise its orbit to 81,000 miles above Earth.
They're getting ready to fire the engines in this very carefully choreographed dance.
There was a planned maneuver, and then the computer shut down.
A shockwave runs through the control room in Tel Aviv.
Suddenly, they can't fire the engine, and the moment has passed. What do you do? How do you get to the moon now?
Four days into the SpaceIL mission to put a lander named Beresheet onto the moon surface, something goes very wrong.
The SpaceIL mission control team was getting ready to fire their thrusters, and the timing was crucial. And then right at that moment, the computer shut down.
So you have the Beresheet spacecraft, and it's orbiting Earth, and in order to proceed, the next step is to do a controlled burn. That has to happen at a specific point in the orbit, and those commands are sent to the computers on board the spacecraft. If those computers fail, if they go down, then you can't send those commands and you can't make it to the next step.
People work their entire life to build a spacecraft which could be lost in the matter of seconds if there is only one tiny malfunction.
You think your spacecraft has failed, your life's work has just come to an end. But then they get to work. Let's solve the problem. Let's find out what happened, fix it, and get the spacecraft going again.
Fortunately, they have put procedures in place, both built into the spacecraft and things that they can do in communication with it from mission control in Tel Aviv to recover from this.
They fixed the software, but they accidentally did more of their smallest orbits than they wanted to do, so they had to do some recalculations. It turns out Beresheet needed to do fewer of the larger orbits. They did all the math. They found a way. They can still get to the moon. They think now that maybe it was cosmic radiation, or maybe the radiation of the Van Allen belt.
The Van Allen belts, those belts of radiation that were discovered right at the beginning of the space age. There is intense radiation, particles that are held in place by the Earth's magnetic field. It's pretty intense, and those can definitely cause this kind of shutdown that we saw.
What we call a single event upset. A charged particle shoots through the electronics of the spacecraft, and it changes a 0 to a 1, or it changes a 1 to a 0 in the computer code. Just a single proton from space shooting through the wrong part of your spacecraft could end your entire mission.
With the Beresheet back on track, the module connects with thousands of followers back on Earth using social media, sending back a quick video, and of course, a selfie.
This is not a simulation. We have a real spacecraft floating in space right now.
The spacecraft managed to get a snapshot of part of itself, and then all of us, the whole of Earth behind it. And it was just that sense of perspective that space travel gives us.
It's a good reminder that we are all from Earth, and as we go explore these other planets, it's something that brings everyone together.
To stay on course, this 21st century spacecraft uses an optical device that captures light from distant stars to help navigate its complex journey.
The team on the ground is checking in with the spacecraft to make sure everything is okay, everything is healthy. Keeping track of exactly where the spacecraft is a little bit difficult. Space is huge, but we want to know exactly where it is. It's best if the spacecraft can do it on its own, so it uses star tracking. The stars are relatively stable compared to the spacecraft that's moving around the planet. The spacecraft uses the position of those stars to keep track of where it is and make sure it's in the right spot.
It's day 42. As the Earth's gravitational pull grows weaker, engineers at Mission Control must fire the Beresheet booster at just the right moment, in the riskiest maneuver of the entire mission, lunar capture.
The Beresheet spacecraft is going further and further away from the Earth until it reaches a distance of about 400,000 kilometers, which is the distance of the moon from the Earth. At that point, it's supposed to intersect the orbit of the moon.
All of its energy has been spent just getting there. So it's going very slow. It's about to start falling from the Earth. But here comes the moon, and the moon has its own gravity well.
And now a real ballet takes place. It is choreography, because you have to burn for exactly the right amounts of time, and you have to be pointed in exactly the right direction.
If Bereshit doesn't fire its engines at the right time, or with the right amount of thrust, then it will actually be whipped by the gravity of the moon into a crazy direction. It will go flying off into space. It's risky. The mission might fail.
This is really a very critical moment for us. I want to thank all of you who've given us your support. I'm crossing my fingers, and I'm not superstitious.
It's April 4th, 2019. The SpaceIL team at Mission Control issues a series of commands to bring the Bereshit into position for lunar capture.
Getting the spacecraft from Earth orbit to lunar orbit is a very tricky problem. There's lots of moving parts. The spacecraft is moving, the Earth is moving, the moon is moving around the Earth, everything is spinning.
It is intricate, and if anything goes wrong, you probably are going to miss the moon.
The Bereshit is trying to hit a precise window during which the onboard engines must fire and slow the vehicle down enough to be captured by the moon's own gravitational pull.
The highest orbit has to put it at the altitude of the moon right at the exact moment that the moon gets there too.
The navigation system has got us pointed in the right direction.
The Bereshit is there waiting.
The engines are working well.
The moon catches up, and Bereshit literally falls into the gravity of the moon.
For that fact to be low, thanks to the...
The capture is successful, and the Bereshit is now in lunar orbit.
We've been very anxious, but we've really got an amazing team, and our luck is still holding.
The Bereshit's first views are a rare glimpse of the moon's dark side, and the module's camera sends back striking images of large craters, some of which are more than 4.5 billion years old. As lunar gravity takes control of the module's path, the primary scientific experiment on board kicks into gear, measuring the strength of the moon's magnetic field as the craft flies overhead.
They've included a magnetometer developed by UCLA and by the Weizmann Institute to measure the magnetic field around the moon and at the location where it's landing.
This valley has seen mankind complete its first evolutionary steps into the universe.
Their landing site is at the Mare Serenitatis. One of the Apollo missions went to the edge of that mare, and so from some of the rocks that were brought back from there, we know that the magnetic anomalies are interesting scientifically.
The moon doesn't have a strong magnetic field, but when the Apollo missions brought back samples, some of those samples had a magnetic signature that tells you that there's something more complicated going on. So the magnetometer on the Bereshit is going to tell us more information about what's going on the moon and what the magnetic history is there.
Correlating the magnetism of moon rocks with their relative ages will yield new information about how the moon was formed.
That will give us fundamental information about the history of the entire solar system.
And knowledge about the origin of the solar system is critical to our search for sustainable environments beyond our galaxy.
There's a great science fiction book, a classic book called The Moon is a Harsh Mistress, and truer words were never spoken.
SpaceIL engineers wanted to land somewhere that wasn't too hot. They didn't want to land right on the equator of the moon, because when the sun comes up, it gets hotter faster at the equator. They wanted to be at a higher latitude.
The moon is alternately one of the hottest places in the solar system and one of the coldest places in the solar system.
If you want to design a spacecraft to survive in that environment, it has to somehow get rid of the heat when it's hot, and it has to somehow keep itself warm when it gets cold. That requires a lot of additional systems on your spacecraft. And quite frankly, it's stuff that could just get in the way and break en route to the moon. So, if you want to have a really simple mission for your first mission, plan to just last a couple of days.
They're going to land on the moon at a very specific time, at dawn, or just a bit before, as their section of the moon is transitioning from night to day. And during that period, the temperatures will be just right. But that won't last long, because over the 2 days that Beresheet is sending data from that magnetometer back to Earth, it's going to start to get very, very hot. This means the Beresheet will have about 48 hours to do all of this work.
Another key component of the Beresheet mission is a collaboration between SpaceIL and NASA. In addition to providing communication support, NASA has added a simple but powerful piece of equipment to the module called a retroreflector.
The retroreflector is the special mirror that no matter what direction a laser beam hits it at, that laser beam is going to be reflected back exactly to where it came from. The one that is being carried by Beresheet will be hit by a laser that is on a lunar orbiter.
The Lunar Reconnaissance Orbiter, or the LRO, is a spacecraft that NASA put into orbit around the moon. It's been there for about 10 years now, doing lunar science. One of the things it has on board is a laser altimeter, which is going to allow it to ping the location of Beresheet.
The lunar orbiter will be able to determine very precisely the distance between that orbiter and the Beresheet.
These retroreflectors will remain functional for at least several decades and will enable future lunar missions to navigate this region of the moon with far greater precision. And anyone from anywhere in the universe that happens to land near the Beresheet will find one very special additional item that the SpaceIL team tucked on board.
We made a time capsule. And that time capsule, I think, incorporates the dreams and hopes of all of those who were involved in building the spaceship. And I have a little part of the time capsule to show you. That's the entire Bible inscribed in this small coin. You can actually zoom in here and see the letters and read it out. Each letter is the size of a microbe.
So here is this depository on the moon for anybody that might go there someday, maybe from somewhere else across our galaxy, and be able to say, huh, there were people living on this planet 2 million years ago. Look at all the cool stuff they came up with.
The onboard science and future legacy of the Beresheet module all depend on the most difficult part of the entire mission, landing.
Space is risky. There are no guarantees. You hope that everything's going to succeed and everything will go right, but there's still that chance.
As they're falling down toward the moon, they're speeding up. They need to fight that with their engine. They need to slow it down to 0. But if you reach 0 velocity a little bit too high, you hit the moon too hard and your mission ends.
A 250,000 miles from Earth, the Beresheet spacecraft approaches its final orbit of the moon at a vertical speed of 105 miles per hour.
We're in a very low orbit. Once we start the descent, there's no going back. Tonight's the crucial time.
Inside the SpaceIL control room, mission engineers focus intently on the most critical phase of the mission, sticking the landing.
Beresheet is in a circular orbit around the moon, less than 200 miles above the surface, after 4 million miles. The moon is so close, you feel like you could reach out and touch it.
We're about to start the landing process. We're going to orient the spacecraft so that the engines are pointing to brake us in our maneuver towards the moon.
Instead of orbiting around the moon, it starts falling toward the surface.
We have a few seconds where the spacecraft will decide by itself if everything is okay. If it decides everything is okay, we're in a non-return point. We're in the landing process.
As Beresheet hurtles alone through space, it makes the call. It's go time.
We have passed the point of no return. There's nothing more we can do.
As it descends to the lunar surface, the Beresheet fires off a photo from space, taken from an altitude of 14 miles above the moon.
The background of the moon as we are approaching the landing site.
As they're falling down toward the moon, through the moon's gravity speeding up, they need to fight that. They need to slow it down.
We are in the braking process. You can see the velocity as we are slowing down.
The Beresheet fires retro rockets to control that descent as it approaches the surface.
As data streams into the control room, the velocity indicator shows a vertical speed just above the lunar surface of 150 miles per hour. Instead of slowing down, Beresheet is speeding up.
We seem to have a problem with our main engine. We are resetting the spacecraft to try to enable the engine. The main engine is back on, but we have lost communication with the spacecraft.
At 500 feet, the Beresheet signal goes silent. As dozens of highly trained scientists process the silence, one thing becomes immediately clear. The Beresheet isn't going to land. It's already crashed.
We had a failure in the spacecraft. We unfortunately have not managed to land successfully. It's a tremendous achievement up to now.
Well, we didn't make it, but we definitely tried. And I think that the achievement of getting to where we got is really tremendous. I think we can be proud.
Despite the disappointment of not landing intact, after nearly 50 days and more than 4 million miles in orbit, the SpaceIL team has pulled off an incredible achievement.
I want to say, we didn't reach the moon in one piece. That sucks. However, engineering and sciences are hard. Sometimes it doesn't work the first time. Sometimes it doesn't even work the fourth time. But eventually it will work. And I want to encourage the kids that might be watching us to continue studying engineering and sciences, because one day you will be able to reach the moon, the stars, and beyond.
Thousands of years from now, we're going to look back at these next few decades as the moment in time where the human race evolved beyond the bounds of Earth. And it will be because entrepreneurs saw the potential.
Three people like you and I who had a dream, they decided to take it upon themselves to land on the surface of the moon.
We're living in a time where small teams can dream big dreams, where there's no shortage of capital, there's no shortage of technology, and there are no limitations.